Built over 4,500 years ago, it contains around 2.3 million stone blocks, each weighing between 2 and 15 tons. Some stones even exceed 70 tons. Now pause and think logically. There were no cranes, no steel tools, no engines, and no modern mathematics as we know it. Yet the pyramid stands with near-perfect alignment to the cardinal directions, accurate to within 0.05 degrees. That level of precision would challenge many construction projects even today. The real mystery isn't that the Egyptians built it, it's how efficiently they did it. Estimates suggest the pyramid was completed in 20 to 25 years. That means placing one massive stone every few minutes, day after day, without error. This forces us to question a lazy assumption that ancient people were primitive. They weren't. They had advanced planning, logistics, and a deep understanding of materials. So the question is not did they have technology? The real question is, what kind of technology did they have that we've underestimated or misunderstood? And that's where the real story begins. Let's address the biggest excuse people make: they just dragged the stones. That answer is incomplete and intellectually lazy. Dragging multi-ton limestone blocks across desert sand would create massive friction. Yet experiments show that the Egyptians likely used watered sand, reducing friction by nearly 50%. This alone cuts the required workforce dramatically. Then there's the ramp problem. A single straight ramp long enough to reach the pyramid's height would be longer than the pyramid itself and require more material than the pyramid, which makes no sense. This is why many engineers support spiral ramps, zigzag ramps, or even internal ramps built into the pyramid structure. In fact, modern scans suggest hidden corridors that could support this theory. Even more interesting is their use of simple machines, levers, sledges, counterweights are applied with extreme precision. No magic. No aliens. Just physics, scaled intelligently. The uncomfortable truth is this: ancient Egyptians didn't lack technology, we lack respect for their intelligence. And once you accept that, the Great Pyramid stops being a mystery and starts being a masterclass in forgotten engineering. One of the most disturbing facts about the Great Pyramid is not its size, it's its precision. The base of the pyramid is level to within 2 centimeters across 230 meters. Let that sink in. Even with laser levels today, that's difficult. So how did they do it? Evidence suggests the Egyptians used water-filled trenches as natural leveling tools. Water always finds level, no advanced maths required, just intelligence and patience. This simple method allowed them to create an almost perfectly flat foundation. Then there's alignment. The pyramid is aligned almost perfectly to true north, not magnetic north. This means they were tracking stars, likely using the circumpolar stars, rotating around the north celestial pole. They weren't guessing, they were observing the sky with discipline. What people avoid admitting is this: precision like this requires standardized measurement systems. And yes, the Egyptians had them. The royal cubit was consistent across the entire structure. This wasn't trial and error. It was repeatable engineering. Once you accept that, the pyramid stops looking like a miracle and starts looking like the product of a civilization that valued accuracy over speed. Forget the Hollywood version. The Great Pyramid was not built by slaves. Archaeological evidence destroys that myth completely. Workers' villages discovered near Giza show organized housing, bakeries, medical facilities, and even burial sites. Slaves don't get proper burials next to kings. Skilled workers do. This was a state-level project involving rotating teams of trained laborers, farmers during flood seasons, engineers year-round, and specialists for stone cutting and transport. This wasn't chaos. It was logistics. Food records suggest workers were fed high-protein diets, bread, beer, onions, and meat. A weak workforce can't move multi-ton stones. The Egyptians understood human limits. What's uncomfortable here is this: they managed supply chains, workforce rotation, and project timelines without spreadsheets, software, or electricity. Modern people like to feel superior. But the truth is, if you removed our technology, most of us couldn't organize a project on this scale at all. The Great Pyramid wasn't built by force. It was built by coordination. Here's where skepticism usually kicks in. How did they cut granite with copper tools? Short answer, they didn't cut it the way you think. Copper was used mainly as a tool holder, not the cutting edge. The real work was done by quartz sand, which is harder than granite. By combining copper saws with abrasive sand and constant motion, they slowly but precisely cut stone. This process wasn't fast, but it was controlled. Tool marks found on stones match this method exactly. Modern experiments have replicated it successfully. Drilling was done using hollow drills, again with abrasives. That's why ancient drill holes show spiral markings, not random damage. The takeaway is simple and uncomfortable. We underestimate slow, disciplined methods because we're obsessed with speed. The Egyptians traded speed for accuracy and repeatability. And that's why the pyramid still stands while many modern buildings don't. This wasn't primitive technology. It was technology optimized for its time. For decades, the biggest unresolved problem of the Great Pyramid has been embarrassingly simple. Where did the ramps go? If the pyramid was built using massive external ramps, we should see physical remains. We don't. Not fragments. Not foundations. Nothing meaningful. That absence is not an accident. This is where the internal ramp theory, proposed by French architect Jean-Pierre Houdin, becomes difficult to ignore. Instead of relying on one enormous external ramp, the Egyptians may have built a spiraling ramp inside the pyramid itself, running just beneath the outer casing stones as construction progressed upward. This idea immediately fixes several engineering problems that traditional theories can't. First, it eliminates the need for a ramp longer and larger than the pyramid itself. Second, it drastically reduces material waste. Third, it allows stones to be raised incrementally as the structure grows, instead of dragging them ever higher along an external slope. Modern technology makes this theory even more uncomfortable for skeptics. Thermal imaging, microgravity surveys, and density scans have revealed internal anomalies, areas that are less dense than solid stone. These patterns align with what internal corridors would look like. It's not final proof, but it's far from coincidence. Here's the detail most people overlook. An internal ramp would allow continuous construction, sheltered from desert winds and extreme heat. Workers could operate year-round with fewer interruptions and greater control. That level of efficiency doesn't come from improvisation. It implies long-term architectural planning from the very first stone laid. If this theory is correct, the Great Pyramid isn't a solid block of stone. It's a layered system, a structure with hidden infrastructure, engineered with foresight most modern projects still lack. And that makes it far more impressive than a miracle story ever could. At this stage, many people panic. The engineering feels too good, so they reach for extremes, lost machines, vanished super-civilizations, or aliens. Let's be clear, that's not curiosity. That's intellectual escape. There is zero physical evidence of advanced machinery, electricity, or unknown materials at Giza. No components. No residues. No tool marks that demand futuristic explanations. None. What we do have is overwhelming evidence of highly intelligent systems built using simple tools. Copper saws combined with abrasives. Sledges optimized with friction control. Geometry applied consistently, not casually. Workforce logistics scaled over decades. That's not magic. That's applied engineering. Here's the uncomfortable truth people avoid. Extraordinary results don't require extraordinary technology. They require discipline, time, and repeatable systems. And modern society is bad at all three. The Egyptians planned projects that outlived individual workers. Knowledge was transferred, standards were enforced, and mistakes were minimized through repetition. That's how you move millions of stones without chaos. Fantasy explanations don't honor ancient people, they diminish them. They quietly suggest humans like us couldn't have done this without help. But they did. With no shortcuts. No hacks. No myths. The Great Pyramid stands as proof that intelligence isn't defined by microchips or machines. It's defined by how well a civilization can organize itself around a long-term goal. And that lesson is far more threatening than aliens ever were. Over 4,500 years later, the Great Pyramid is still standing, while modern buildings sometimes fail within decades. That's not luck. It's not mystery. It's structural logic. The pyramid's shape is brutally efficient. Weight is distributed downward and outward, minimizing stress points. There are no flat roofs to sag, no fragile corners, and no unnecessary voids that weaken the structure. Every stone contributes to stability. The outer limestone casing blocks were cut with extreme precision. The gaps between them were thinner than a sheet of paper. This limited internal movement, reduced erosion, and prevented vibration damage over time. Even seismic activity has little effect on pyramid structures. Their low center of gravity and massive weight dampen shocks that would crack vertical buildings. Now compare that to modern construction. Speed. Cost-cutting. Thin margins. Materials chosen for convenience, not longevity. This comparison is uncomfortable because it exposes a truth we don't like admitting: the Egyptians built with time horizons longer than human lifespans. They weren't designing for investors, elections, or quarterly results. They were designing for permanence. That's why the Great Pyramid isn't just an ancient monument. It's a standing critique of how modern engineering often values efficiency over endurance. And until we relearn that mindset, we'll keep building faster and lasting less. You would think that after centuries of excavation, measurement, and academic obsession, the Great Pyramid of Giza would be fully understood by now. That assumption feels reasonable. After all, it is one of the most studied monuments in human history, yet it is completely wrong. Every generation of archaeologists and engineers seems to uncover new questions rather than definitive answers, and the more we know, the more we realize how much remains hidden beneath those ancient stones. In the past decade, scientists have begun using a remarkable technology known as muon tomography to peer inside the pyramid. Muons are subatomic particles created when cosmic rays strike the Earth's atmosphere. They pass through stone, but not evenly. Denser areas block more muons, voids let more through. By placing highly sensitive detectors inside and around the pyramid, researchers can track these tiny particles and create a detailed X-ray of its internal structure without drilling, chiseling, or disturbing a single block. This method has allowed us to visualize the pyramid in ways that were impossible even 20 years ago. The results were, for many experts, profoundly unsettling. The scans revealed a large void above the Grand Gallery, stretching tens of meters in length. This space is not a natural crack, nor the result of structural failure or erosion. It was deliberately constructed, and its precise location indicates careful planning rather than accident. The implications are significant. Why did the builders create this space? Was it a stress-relieving chamber to distribute weight more evenly? A temporary corridor used during construction? Perhaps it served a symbolic or ritual purpose. The uncomfortable truth is that, after thousands of years, we simply do not know. And that uncertainty is precisely what makes this discovery so important. It demonstrates that the Great Pyramid contains intentional architectural features that were never documented, never recorded, and never obvious to external observers. These features are not mistakes or oversights, they are deliberate design decisions. For modern engineers, the concept is striking. Empty space, in conventional construction, is often considered wasted. Yet in advanced structural design, voids can serve critical purposes, controlling stress, redistributing weight, or preventing collapse. In other words, absence can be as critical as mass in creating stability. Even now, leading engineers openly admit that some of the pyramid's internal features remain debated because, while we cannot yet fully explain the reasoning behind them, the structures work perfectly. Tens of thousands of years later, the Great Pyramid stands firm, balanced, and intact, a testament to an engineering understanding that exceeds our ability to replicate it fully. So no, the Great Pyramid's mystery does not stem from magic or lost technology. Its enigma arises from the fact that its builders left no blueprints, no manuals, no instructions, just a finished structure that continues to challenge and humble modern science. That silence forces us to confront an uncomfortable reality. Our technological advancement does not automatically mean we understand what humans have achieved in the past. In some areas, we are still reverse engineering brilliance, not surpassing it, and that truth is more impressive and humbling than any mythical explanation ever could. After centuries of theories, experiments, scans, and debates, the final conclusion about the Great Pyramid of Giza may feel almost anticlimactic because it isn't flashy enough for headlines. There are no hidden machines, no lost super technology, and certainly no aliens. The pyramid's secret is far simpler and far more profound. The real secret is systems thinking. The ancient Egyptians approached the pyramid not as a single, impossible task, but as a massive, highly controlled project broken down into repeatable, manageable processes. This is where modern audiences often fail to grasp the scale of the achievement. They assume genius comes from inspiration alone, from a miracle or a flash of brilliance. In reality, the pyramid was a triumph of organization, planning, and consistency over decades. Every aspect of the project was standardized. Stone blocks were cut to uniform sizes wherever possible, reducing variability and making placement predictable. Workflows were carefully structured so that the laborers' tasks didn't require constant decision-making or improvisation. Simple machines, levers, sledges, ramps, and counterweights were not used sporadically, but applied consistently and intelligently across the entire construction. This created a repeatable process where mistakes were minimized and efficiency maximized. Labor was organized at scale. Skilled workers were trained, rotated in teams, and their knowledge preserved and passed down through generations. Supervisors ensured coordination across hundreds, possibly thousands, of workers at any given time. And most importantly, the Egyptians planned the entire project with a time horizon measured in decades, not months or years, allowing them to maintain discipline and progress over a generation. Every stone wasn't a miracle. The system was the miracle. This is the uncomfortable truth modern societies tend to avoid. We obsess over speed, shortcuts, and immediate optimization. We want results yesterday. The pyramid was built on patience, repetition, and ruthless consistency. If a project like this were attempted today without cranes or modern machinery, most teams would not fail because of intelligence. They would fail because they couldn't sustain discipline over 20 or 30 years. Budgets would shift, leadership would rotate, priorities would change, chaos would replace coordination. The Egyptians didn't build for quarterly outcomes or fame. They built for permanence. Every decision, every stone, every ramp reflected foresight far beyond a single human lifetime. That's why the Great Pyramid still stands, not as a monument of mystery, but as a mirror reflecting how poorly modern civilizations understand long-term thinking, coordination, and restraint. If this series has made you rethink what ancient civilizations were truly capable of, don't just watch and move on. Subscribe to the channel for more deep dive breakdowns where myths are challenged, shortcuts are exposed, and real engineering finally gets the respect it deserves. The Great Pyramid is not just history. It is a lesson in vision, planning, and systems thinking, one we ignore at our peril.